Griffiths Electrodynamics, problem 2.31. And we are looking at these three charges which are located at the corners of a square, side A, as shown in figure 2.41. How much work does it take to bring in another charge plus Q? So we're looking at bringing one into this location from far away and place it in the fourth corner. All right, so we just have to basically find, we're just going to use superposition and find what the potential is right here. Then the work will just, since we're calling zero potential out at infinity, the work will just be this. When we bring the charge in from infinity, it'll just be this charge Q multiplied by that potential from these other three charges, and that will give us the work required to bring this in. All right, so in order to do this, let's just go ahead and start working on the potential. So there's going to be a common 1 over 4 pi epsilon naught factor. I'm just going to factor that out front and then start from there. So we have to basically, we'll just see what the distance is from this point to each of these, and we'll basically add all these things together. Since we're working on the potential first, there's only going to be one factor of charge in the top. All right, so let's start with the hard one first. Why not? Let's start with this one, right? Right. So we know that the distance from between the corners of a square will be the side multiplied by the square root of 2. All right, so that's our, well, yeah, let me just write out a more generic form real quick. So I'll just say Q1 and then curly R1 plus Q2 and then curly R2 or cursive R or whatever. All right, and I'll just do 3 terms since there's only 3 charges that we're looking at. All right, so this is more general idea of what we're doing. To get the potential, we need the charge that we're looking at, one of these 3, right? And then the distance to the point where we're going to bring this fourth charge in. So that's what these R's are. Okay? All right, so let's go ahead and start on a new piece of paper. All right, so leave the 4 pi epsilon naught out front. All right, so now we'll start with this hard one. Now that we've kind of made sure we're clear on the general framework of things, Q1 is just this, since we'll call this 1, okay? Q1 is just going to be this plus Q, and this distance right here is going to be A over square root of 2. Like that. All right. Now, really easy. We'll just do this for 2 and 3. Why not? Let's call this one 2, this one 3. The distance between these points and the point where we're bringing this fourth charge is just A, since it's a square. All right. I'll use a plus sign here, and we'll use a minus Q for number 2 over the distance, which is A. And we're going to do the same thing over here for number 3. So a minus Q on top over distance A. All right. Probably could have skipped a bunch of steps on that one, but we just want to make sure we go carefully. Let's go ahead and factor out a cube as well. Okay. So basically what we have, why not? Let's factor out an A too. Squeeze an A in there. All right. So here we had we factored out the Q, we factored out the A, we have a 1 over square root of 2, and then a minus sign we factored this whole thing out, so we have a 1 here and a 1 here, but they're minus 1, minus 1. All right, so whatever, I won't write this again, you know. This is a minus 2, okay. All right, so the work is equal to the charge we're bringing in multiplied by this potential. And since the charge is just a plus Q right here that we're bringing in, here we go. We just end up with a Q squared out up on the top, our 4 pi epsilon naught. We have an A, and then here we have 1 over square root of 2 minus 2. And so there is the work required to bring a positive charge Q in from infinity and place it at the corner of this triangle with these other 3 charges. Right, there's also a part B to this problem. How much work does it take to assemble the whole configuration of 4 charges? So, bring these back up. We've got, all right, so all 4 of these charges. All right, so basically we're just going to do the same thing we did before, except start with the potential of what's already there. And we already know the last term because we just found it, so we know how much work it takes to bring in the 4th charge. The first one, there's no charges there already, so we get that one for free, right? So let's go ahead and sum up the work required to bring in these 4 charges. And rather than worry about the potential, I'm just going to put the charge in there and call it work, right? So basically, it's the same as finding this potential, just with putting the Q's in as we go. All right, so let's talk about the first one, work 1. You know what? We'll call W equals W1 plus W2 plus W3 plus W4. All right, and this previous one that we found was the 4th charge, right? So we already know W4. And we know W1 because there aren't any charges there already, so the potential 0 and the work 1 is going to be 0. Okay, so now we have to find W2 and W3, basically. So look at our picture. W2. All right, so we'll have our 1 over 4 pi epsilon naught out front. And then for the first one, we have a minus charge and a plus charge. So there's a minus Q squared. And at this point, there's only these 2 charges. There's only 1 charge we have to worry about and 1 distance we have to worry about. The distance is A. And there is our first, this is our W2, okay? So now we know W1, we know W2, and we know W4. We still have to plug in W4, which we'll do at the end, and now we have to find W3. Okay, so there's still our 1 over 4 pi epsilon naught. Okay, so now we're looking at this charge right here. Well, so there'll be 2 terms, one which really deals with the potential from this charge, and one which is charge number 1, and one which deals with the potential from charge number 2. So we're working against both of these potentials to bring this charge in, right? This one's not here yet. We haven't done 4 yet. So now we're bringing in this and, with respect to this one and this one. All right, so first we have, let's go with respect to 1 first. So we have opposite signs. So we have a minus sign again. And the distance is a. Okay. And then we have another term here. These are like charges, so we'll have a plus sign, q squared, right? And then it's another diagonal here, so the distance is a square root of 2. Okay, now you'll have to have patience here because we jumped down the line. So if you just follow this out right down here. Okay. All right. And so this is W1, W2. This term is W3, and we're going to put our W4 down at the bottom, which we found before. Mess of papers again. Okay. Here's our W4. So I'm just going to add right here in. Okay, so 1 over, I'll just put it in the same form as these ones, 1 over 4 pi epsilon naught. There's a q squared, a square root of 2. I'm putting this q squared and a back in, just so it's in the same form as the other ones. Minus 2q squared over a. All right, so all that's left to do is simplify this expression for part B, which is the total work. All right, so now we'll factor out our 1 over 4 pi epsilon naught. And why not? Let's factor out the q squared over a too. All right. So from this term, which is our W2, we have a minus 1. Okay. From this term, so here's our W3, this part, and we factored out the q squared over a, so we have another minus 1 from this part, and a plus 1 over square root of 2 from this part here. Now our final W4 term, we have a plus 1 over square root of 2. So again, factored out the q squared over a, brought it out here. And then here we have a minus 2. Okay. I think it's the same. Okay. All right, so here we go. 1 over 4 pi epsilon naught. Marker's getting a little dry. And we have a minus 4, so if I add a minus 1, and minus 2. And then here we have 2 over square root of 2, because we're adding up these 2 1s over square root of 2. So there's 2 of these. And there we go. So, I mean, we can factor out a 2 here if we want, but we can just leave it as it is. And that's our answer to part B. So this is the total work required to put together 4 point charges in the middle of infinite empty space. So no other charges, nothing else in the universe except for these 4 charges, which we bring from infinity and put together in a nice little square of side A. Useful stuff.